Here's a question with an obvious answer. Do you know what a sentence is? A paragraph? How about a comma or a question mark? Well, here's an equally fundamental question with a less obvious answer. Do you know the basic number properties? Commutative, associative, distributive, identity. The number properties that kids learn in first or second grade are behind everything else they do in math. They're like grammar. They're the foundational rules for how we manipulate numbers and perform operations. So why does it seem like no one knows them? In early elementary school, kids learn the names of the properties, the definitions, and they apply them to a handful of problems. But we need to keep coming back to them over and over again throughout the years, just like we do with grammar. Because mastery of these properties prevents a lot of trouble later on. Here's an example. Your child is asked to add 2/3 plus 5/6, but they can't add these fractions as they are because they don't have the same denominator. So they need to convert one of the fractions into an equivalent fraction that uses the same denominator as the other one. So I'm going to take 2/3 and convert it into sixths. Now, sometimes kids learn in school to do this. But this doesn't really make a whole lot of sense because it doesn't have a whole lot of meaning, that you're just multiplying the numerator by 2 and multiplying the denominator by 2. And sometimes kids will forget that they have to do that to both numerator and denominator, and they'll just do this because now they have sixths and they'll just keep the 2. And this does not work. This is where an understanding of the identity property of multiplication really comes in handy. The identity property, in this case of multiplication, is really straightforward. It just says that when you multiply any number by 1, that number retains its value. So a times 1 still equals a. This is really obvious in and of itself, but it has applications to harder problems that are not quite as obvious, like our fraction problem. 2/3, if we want to make it into sixths, we multiply the whole fraction by 2/2. Because 2/2 is equivalent to 1. Anything over itself is 1, because anything divided by itself is 1. And when we multiply a quantity by 1, the quantity remains the same. So even though it will look different, 2 times 2 is 4, 3 times 2 is 6, these two fractions are still the same amount. Here's another example. The area of a circle is 45 pi. Find the diameter. So your kids will go through a few steps to find the diameter of the circle. First, they'll use the area formula, pi r squared, to find the radius of the circle. Once they find the radius, they can double that to get the diameter. So once they do all this work, they'll find that the radius is 3 radical 5. But what often happens is that the very last step, doubling 3 radical 5, trips kids up. They'll ask, all right, 2 times 3 radical 5. Do I double the 3, or do I double the 3 and double the radical 5? And this is where a real understanding of the associative and distributive properties will help. The associative property of multiplication in this case says that when 3 numbers are multiplied, the product will be the same regardless of how you group those numbers. The distributive property of multiplication over addition in this case sounds complicated, but it's really quite simple. It just says that if you multiply the sum of 2 numbers by a third number, then the answer is the same as if you had multiplied each of these numbers by the third number and then added them together. So 4 times 5 plus 2 is 4 times 7, and 4 times 7 is 28. But I could also multiply each of these addends by the third number. So 4 times 5 is 20, and then 4 times 2 is 8, and 20 plus 8 is 28. So since 3 radical 5 is 3 times radical 5, and 2 times 3 radical 5 is 2 times 3 times radical 5, we have 3 numbers that we're multiplying together. And we know based on associative property that we can group those in any way we like, and the product will be the same. If I group the 2 and the 3, and then multiply that by radical 5, I end up with 6 radical 5. If this problem had been 2 times 3 plus radical 5, then we would use the distributive property and double the 3 as well as double the radical 5 and then add them together. But since 3 and radical 5 are connected by multiplication instead of addition, we use the associative property and not the distributive property. So mastery of the basic number properties allows students to answer their own questions, to figure out how to perform an operation without going to the teacher, and to solve problems in their own way. It's similar to how knowledge of grammar allows a student to write an essay that no one has ever written before. This is not small stuff. Competency in the basic grammar of math gives students independence and it gives them power.